All right, so this is an introduction to what's called a two-sample mean comparison test. When I say test, I mean hypothesis test. Okay, so we're going to do a hypothesis test, and instead of a one-sample hypothesis test, this is a two-sample hypothesis test. And what are we going to do in this test? We're going to compare two means. We're comparing two means from different samples and possibly from different populations. So when we say two samples, what we mean is we're going to have two different mu's. We're also going to have two different sample means, two x bars. We're going to have two standard deviations, two sample standard deviations, S1 and S2. Why? Because there are two samples. For every sample, we have a mean. So one sample mean, two sample means. One standard deviation, two standard deviations. One sample size and two sample sizes, okay? And what we're typically doing is we're taking two different population means, two different mu's, and we're testing, we want to see if the two mu's are equal to each other, okay? That is the null hypothesis. Our starting assumption is that the two means from the two different samples, or that the two samples are from the populations, we assume that the means of the two populations are equal to each other. And basically what that means is that they're coming from the same population, okay? But isn't it possible, alternatively, meaning alternative hypothesis, maybe it's possible that mu1 is not equal to mu2. This would be a two-tailed test. It's also possible that mu1 is less than mu2. That would be a left-tail test. It's also possible that mu1 is greater than mu2, and that would be a right-tail test, okay? And so this is everything that we're going to be looking at in the two-sample mean comparison test, okay? Now, this two-sample mean comparison test, this is called a t-test. Now, we haven't seen a t-test. We've only done the z-test, okay? This one is called a t-test. The t-distribution is very interesting. Instead of just being a single distribution like the z-distribution, the t-distribution is actually a family of symmetrical distributions that are related to the normal distribution, kind of like a bunch of cousins, okay? And what you have to first do in order to use the t-distribution, the first thing you have to do is you have to pick the cousin that you want to use based on something called the degrees of freedom. So if your degrees of freedom are 7, you get one cousin. But if your degrees of freedom are 8, you get a different cousin. So the very first thing you have to do in using the t-distribution is you have to pick your degrees of freedom. And the way we're going to do this, and I'll show you right now, is we're going to go into NumWorks and we're going to choose, instead of choosing the normal distribution, we're not going to choose the normal distribution. We're going to choose what's called the student's t-distribution. Then we have to choose our degrees of freedom, and then we use it in the very same way that we use the normal distribution. So here is the NumWorks calculator. We'll go down to distributions, we'll hit OK, and when we go down, here's normal, but we're going to keep going. One you haven't seen yet, down here, there it is, students t. So we're going to select, for this kind of test we're going to do today, we're going to use students t. Then when we go to the right, the very first thing it says is, which cousin do you want? What are your degrees of freedom? Your degrees of freedom, they can be 2. Your degrees of freedom can be 457. There's a lot of cousins in the student's t-distribution, okay? So when we do finally pick a cousin, let's say we pick a cousin with 17 degrees of freedom, and then we hit next. Whoops, hang on a second here. Oh, here we go, next. I gotta hit OK here. Next, it's not, look, it looks just like the normal distribution. And we use it the exact same way. We come over here and look, we can do a left tail test, we can do a middle test, we can do a right tail test, we can put our critical value in here or our test statistic in here, we can put our p-value over here, we can get our p-value from here, we can get our critical test statistic from here, it's all the same. We're going to use it the exact same way that we use the normal distribution, but it's just not the normal distribution. It's student's t-distribution. But it is basically in every other way identical to the normal distribution. And the only real difference is that before we use it, we have to tell the calculator what the degrees of freedom are. We got to tell the calculator which family member, which cousin we want, okay? All right, so that's it pretty much for our introduction to the two-sample mean comparison test. In the next video, we're going to go through the procedure, the step-by-step procedure on how to conduct a two-sample mean comparison test.